Good morning. I'm Steve Wall. This is Magellan at Venus. Magellan continuing to map, and of course that's the area in which no news is good news. We want that to carry on very smoothly. And today we're going to talk about how everybody gets Magellan pictures. But first of all, let's show you where we are on our map. If we were mapping the world, the Earth, instead of Venus, and if we had started at Los Angeles, then today we would be mapping Melbourne, Australia, heading out over the Pacific Ocean, still headed toward our goal of getting back around, all the way around the planet Venus, or if we were on Earth, back to Los Angeles, by May 15th. On May 16th, of course, we begin the second time around. And with the second time around, we'll be filling in the gaps, most notably the gap of the South Pole, and some other gaps of places where the sun got in the way and other things that we've told you about. And also doing some special tests to figure out what we're going to do on our third time around. But Magellan is continuing well, taking each little strip of data, each 10-mile wide strip, putting it together into these mosaics, which we've shown you in previous programs, and putting those into the scientists' hands so that they can begin to analyze them. But today is a special day for Magellan, because today we have begun another process, the process of getting these pictures to people outside the project. Now that's a very important, and in a way, one of the most important things that Magellan does, is we put all of these images into an archive, a data bank, if you will, in near Washington, D.C., where anyone can have them, not only scientists, but anyone. And not only can these be acquired in terms of pictures and prints and negatives, but these data can now be acquired digitally. And it all happens by a way that some of you are pretty familiar with. I'm sure you all know what a compact disc looks like. Here's what one is. And it's just something that you have music on, okay? You see these as very similar to a record. Okay, this is what you listen to, anything from classical music to rock and roll on. But there is a fundamentally different thing about these discs from records. And that is that records show us music in terms of amplitude variations, of loud versus soft, and frequencies high versus low. What happens on a compact disc is that the music has been digitized, and we now have music that is represented in terms of ones and zeros instead of in terms of loud and soft. Well, ones and zeros can be used to represent music. They can be used to represent encyclopedias, words, dictionaries, and they can also be used to represent pictures. Magellan has chosen to use these compact discs because they are very small and also because they are relatively inexpensive as a way of getting our pictures to the public. Instrumental in that effort has been a gentleman whose name is Jason Hyun, who works here at Jet Propulsion Lab and has taken our images that we've shown you in terms of prints and has put them onto there. Jason, it sounds like a whole black magic kind of thing of getting a picture onto a disc like this. Can you explain how the discs work?
Okay, actually, this is very simple. It uses the same technology as audio technology, like you said, and just use the digital data rather than converting to audio data, like what you would do when you play the audio discs on a stereo system.
Okay.
CD-ROM it lasts about 50 to 100 years, so it's more durable than regular magnetic tapes we've been using for archive and distribution. And it is so cost-effective that if you making a CD is much cheaper than making 60 copies of tapes. What we've been doing was we are storing all the F meters, full resolution mosaics and compressed resolution mosaics, and few of the products developed by MIT, which is called ARCDR and GXDR products.
These are the altimetry and the radiometry information, right? Okay.
And the total set will consist of 56 CD-ROMs, and we'll be releasing it periodically throughout the mission, I guess.
Now you call them CD-ROMs. Is there anything different between a CD-ROM and the compact disc you buy at the local record store?
If you look at physically, there is no difference at all.
Okay.
And one is, containing digital music, and the other one's containing digital data.
Okay, these CDs, these compact discs, are pressed just like a regular record, right?
That's right.
So that from the time that you make the data in the right format They really are handled a lot like records, aren't they?
That's right. One thing good about the CD-ROM is the CD-ROM file format is conformed to the international standard. So if
Okay.
you were to make a one CD-ROM, you will work on all four platforms. When I say platforms, there are IBM PC, Macintosh, Microvexes, and Unix systems.
Okay, these are all different kinds of computers that
Yes.
people might have.
But if you were to have a one CD-ROM, it will conform to all international standards, so you'll work on any operating system.
Okay, which is to say that anybody who has a computer and who has the right reader for these disks
Right.
can access the pictures.
That's right. And JPL has developed a couple of display programs that displays those images from CD-ROM on IBM PCs, Macintosh, and Sun workstations.
Okay, are those kinds of programs available to anybody that wants them also?
Yes, you could obtain it through NSSDC or PDS, which is a Planetary Data Systems in JPL.
Okay, so NASA has a series, actually 2 or 3 different distribution networks that you've talked about. There's the Planetary Data System. There's also the Regional Planetary Image Facilities, which are at major universities throughout the United States, and I guess
Right, there are about
throughout the world,
13, 13 sites in the world.
Okay, so you can go to a university that's not far from your home, and you can see these pictures. That's what the Planetary Image Facilities are about.
That's right.
And if you want to order some of them for yourself, then these people at these Regional Planetary Image Facilities can then help you
Right.
find the images or the disc or the prints or whatever you want, right?
Or you could order it through National Space Data Center, which is located in Maryland.
Okay. Is it true then that anybody, any average person then, can write to the National Space Science Data Center and get these prints? Or
Yes,
these
I
discs?
believe so.
What's the schedule? How will we've had one disc now. What will we do from now on?
Well, we'll be JPL as a system. We have a capability to make one disk per day. However, I think we're going to make one every month or so, and we'll keep on doing that. And then periodically, we're going to release whole sets of CDs at a time.
Okay, so I mean, this must be a huge. You said 56 CDs. That's a huge amount of music.
But each CD-ROM contains about 680 megabytes. So 50
almost
times that is about
almost 1 billion bytes,
Right.
or 8 billion bits
30.
of information on each one of these.
Right.
What else is on the CD? I know there are images. Are there are also some files that tell you how to use the images?
Yes,
right?
we have ancillary documentation, also geofeature database. We have experience data notebook, which contains all the necessary information to analyze the image itself.
Okay.
And they're all contained in the CD-ROM. And it also contains PDS high-level templates, which explains the mission, instrument, all the things that was involved to generate this data. So one CD-ROM self-contains all the references it needs. So people can just look through it, read the documentation, and understand the data without asking anybody else.
Are there other projects that have done this?
Yes, we have so far made 13 volumes of Voyager imaging data, and Viking orbiter data is being stored on a CD-ROM. We have generated 2 Viking CDs so far, and also Mars Observer is planning to generate 8 more CD-ROMs this year containing all the Viking digital data.
Okay, so you really wouldn't have to have a lot of these in order to have basically all the major planetary missions. You said
right.
56, and maybe add another 10 or 15. 60 of these would fit on one bookshelf, right?
That's right.
So one bookshelf contains the last 20 years of planetary imaging?
Yes. And it will last about 50 to 100 years.
How do you know they'll last 50 to 100 years when you haven't had that long?
Well, they have done a lot of quality control, and they have aging test, standard aging tests they've been gone through, and they conclude from that result that it's going to last between 50 to 100 years. And people are almost sure that it's going to last 100 years.
Well, this has been a fairly major effort of JPL's, hasn't it?
Yes.
Can you give us some of the history of how this came about?
Well, starting 1985, you know, people come up with the CD-ROM technology ideas, and there was a standard issued going on throughout the world, and JPL was involved since the beginning of the CD-ROM technology. And we start with the Voyager imaging, and probably released the first Voyager CD-ROM in 1987. And since then, we've been generating all the data on a CD-ROM as much as we can.
So for Voyager, it was a couple of years from the time that they took the data until the time that they got the CDs.
They have all the data stored on tapes before, and now they wanted, since the tapes are degrading, they wanted to convert the data from the tape to CD-ROM, so they will last longer and they could distribute it widely and quickly.
How long has it been for Magellan since we took the data till the time that we got them to the CD?
Well, this is the first disc we released to the public. However, we were making discs since last year, July, and we were getting the data from Magellan spacecraft since last September, and since then we've been generating all the test discs since October.
Since September. Well, can we look at some?
Sure.
Okay, now this, first of all, let's, can we tell people what we've got here?
Okay, this is typical IBM PC system with a VGA monitor, and all you need in addition to the system is CD-ROM player. And you could obtain the CD-ROM player between